we're going to take another look at deriving a parabola's vertex from scratch. And this method is going to be far easier than the other methods we have so far used. I feel a little bit embarrassed that I didn't think about this earlier, to be honest, and presented this first before the other two ways. The assumption we're going to make here is the same assumption we made with the first video, but here we don't have to go through that lengthy completing the square process to derive the vertex from y is equal to ax squared plus bx plus c. First, let's make a few observations. So for example, if we think about ax squared plus bx plus c, we have a parabola. And one thing that jumps out right away is that the y-intercept will be at 0, comma c, because here x is equal to 0. You substitute x is equal to 0, the a goes away, the b goes away, so the only thing that's left is the c. So that c will tell you the y-intercept. Another pretty obvious thing about this graph, for example, is that if a is greater than 0, in other words, is positive, the parabola opens up. If a is less than 0, in other words, is negative, it opens down. We're also going to take for granted that if y is equal to a, parentheses, x minus h, close parentheses, squared plus k, then here the vertex is located at h, comma k. Now in the first video we did a kind of visual intuitive proof of this. So if you think about this equation here, it becomes intuitively obvious that this has to be the vertex. So we're going to take that for granted. But this time we're not going to take this equation here and, so to speak, transform it into this equation via completing the square. We're just going to link up the coefficients. So we're going to link up coefficients. So by linking up the coefficients, we can solve for h. And we'll find out, as any textbook would tell you, that the vertex is at negative b over 2a, comma, f of negative b over 2a. So let's do that. So first we'll expand out y is equal to a times the quantity x minus h squared plus k. We'll expand that out. So a times the quantity x squared minus 2hx plus h squared, close parentheses, plus k. And that's just a x squared minus 2a hx plus a h squared plus k. And then we're going to take this equation here and link it up with the y is equal to ax squared plus bx plus c. So we'll set that equal to a x squared plus bx plus c. And the only thing we have to do here is link up the coefficients. So look at minus 2ah, and that links up with b. Look at this a h squared plus k, that links up with c. So we can just solve for h. So minus 2ah is equal to our b, and we'll solve for our h. So if we divide both sides of the equation by minus 2a, we can say, therefore, h is equal to minus b over 2a. Boom. We're basically done. And look, of course, that this corresponds to what any textbook would tell you. So just by setting the coefficients equal, we can get our vertex. But we can continue with this. So let's do the same thing for k. So we have a h squared plus k is equal to c. Let's solve for k. So k is equal to c minus a h squared. We have our h, so let's substitute that in. So we have c minus a. So minus b over 2a, that's squared. So we get c minus a, b squared over 4a squared. Remember that a is over 1. So therefore, we get k is equal to c minus b squared over 4a. Great. So here we have our hk. Here is the vertex when thinking about the parabola in terms of ax squared plus bx plus c. And we can also note that if we figured out f of minus b over 2a, we would get back this c minus b squared over 4a. So that's pretty simple, pretty easy, pretty cool. There's other things to note here. And I'm going to note this very quickly because I think this is worthy of another video. So for example, so let's just do a bonus here. If we think about if y is equal to a times the quantity x minus r sub 1 times the quantity x minus r sub 2, then r sub 1 comma 0 and r sub 2 comma 0 are x intercepts, right? So let's say we have a parabola, looks like this maybe. So here and here are two x-intercepts. So here's r sub 1, here's r sub 2. What's the relationship with the vertex? Well, intuitively, if we think about it, this x-coordinate of that vertex has to be halfway between r sub 1 and r sub 2. And right now we have the tools to prove that in fact h, which equals minus b over 2a, is equal to 1/2 times the quantity r sub 1 plus r sub 2. We have the tools right now to prove that. And in a future video, we'll do that.